right now. So, hello everyone, and welcome to the February 17th meeting, 2026 of the Colorado Hydrogen Network. And today's Mardi Gras Day, so happy Mardi Gras Fat Tuesday to everybody. All right, so what we're going to talk about today is I'll go over just some news, some of the coming events going on, and talk about a new podcast. Actually haven't listened to it yet, but it's on YouTube and, of course, the audio podcast. And then I'm going to do kind of a deep dive, I guess, and give an overview of this whole idea of geologic hydrogen and talk about the companies and the ecosystem and how this relates to data centers and all those kind of good things. So that's going to be pretty in depth. I've got, I think, 40 some slides on that. So put on your tinfoil hats and we'll get a little bit technical. So tomorrow there is a webinar, I guess you'd call it, that FCHEA, Fuel Cell and Hydrogen Energy Association, is putting on. It's free, and if you use your phone or something to scan the QR code there, you can register for that. I'm planning to tune into that myself, but find out about how hydrogen and data centers kind of relate to each other, which we're going to talk about a little bit on the meeting today. And I'm going to hit mute all on everybody again. So again, if you do want to interrupt, please do so at any time. I just want to keep background noise down, so got everybody on mute. All right, so I've talked about this a couple of times now. There's this so-called World Hydrogen and Carbon Americas that's put on by S&P Global, going on down in Houston on March 10th through 12th, although the 10th is kind of a special seminar day, and the 11th and 12th is the basic event itself. I will be there. I'm going to be running a panel to talk about geologic hydrogen, and this is, I don't know, the second or I guess the third time that I've led a panel at different events to talk about geologic hydrogen. I think it's really important, and you're going to find out more about that today. And then the third annual Drilling for Hydrogen Conference, also coming up in Houston, but that's May 13th and 14th. And see a web address there if you'd like to look at it, get some more information, and possibly register for that. I'm hoping to go to that. I'm not sure yet. I haven't actually booked my travel, but I will be at the March 12th event running a panel. All right, so just heard about this today. There's an organization called Natural Hydrogen Investing, NatH2 Investing. And even though a lot of us probably aren't planning to necessarily throw money into investing in natural hydrogen, still there's some good information. And the latest podcast, I'll call it, although it's a video podcast as well on YouTube, features Vyacheslav Zgonek, who I've talked about now for probably 5 years running. Vyacheslav and I talk all the time. But I visited his well his hydrogen well, which is the first well in North America, back in Nebraska in June of 2020, right after COVID. So anyway, check those out. If you prefer audio podcasts, you can get it on Apple Podcasts. Or if you'd like to watch YouTube, I watch YouTube every day. It's an amazing amount of information you can find out about just about everything there, and find a lot of good information. So check that out, and you can scan the QR codes there for the links. All right, so let's kind of dive into actually kind of a deep dive to talk about geologic hydrogen, or GeoH2. And I want to just kind of do an overview. I did a broad survey of all the companies and techniques and things that are out there, and I think you'll find this interesting. So basically there's two types. There's naturally occurring, or I call it free hydrogen, that can be tapped. And then there's the hydrogen which can be generated in oil reserves. And there's a little bit of crossover here because natural hydrogen can be stimulated, and generating oil in oil reservoirs is kind of a form of stimulation. So it's kind of a Venn diagram overlap there on those things. But natural or free hydrogen, as most of you probably have heard by now, is thought to be found in pockets around the world. And if you're not finding it free form, but you've got the conditions that you think are right, you can also stimulate it using heat and water injection and rock fracturing. And I'll talk a little bit about that. And then in oil reservoirs for, 6 years now, I've been talking about Proton H2 and what they're doing with oxygen injection, which releases hydrogen. But there's also another company which we'll talk about, Eclipse Energy, that can inject microbes down into old oil reservoirs. And these are both clean. There's no carbon, there's no methane involved, and we'll talk about that a little bit more as we go along here. But a little bit different than what we're used to thinking of with steam methane reforming, where you take usually natural gas out of the ground and then you crack the hydrogen out of it, but then you've got to get rid of that CO2, and you don't have to do that with these other techniques. All right, so the companies out there that are really, and this is not intended to be an all-encompassing list. I don't think I know who they all are, and the list changes all the time, but see, these are some of the ones that are more well-known and are more active. Coloma, Top End Energy, which I didn't know about till just recently. Hytera, Gold Hydrogen Limited. You can read the list here, and I'm going to go through the characteristics of each of these and what they're doing. All right, so to start, Coloma, they're actually headquartered in Denver, and they started with a research lab at Ohio State University. And they're also licensing their technology down in Australia, and also they have a partnership with the government of the Philippines. They claim they've got over 20 years of exploration data and proprietary technology, and this is their marketing speak. I guess it's true, but they say they've got a data advantage even greater than the U.S. Geological Survey. So I don't know, we'll have to get to Jeffrey Ellis to comment on that, see if he agrees with that or not. But anyway, that's what they had on their website. So they're currently drilling in Idaho and Kansas and Iowa, and these are areas that are thought to be particularly rich with naturally occurring hydrogen. And, these are all fairly far from large population centers like a Denver or Chicago or San Francisco or something like that, but there are users for the hydrogen in those areas, primarily, especially in the case of Kansas and Iowa, the agricultural areas that can use the hydrogen for making ammonia. So they've got Coloma's got quite a bit of financial backing. This is a fairly old news story, but Breakthrough Energy, which is Bill Gates' foundation, gave them at least $90 million. I think there might have been a second award to them. Apparently Amazon and United Airlines are also throwing some money at them. So if you want to learn more, you can find them at coloma.com. All right, Top End Energy. They're based in Australia, but they're prospecting in Kansas and Australia's Northern Territory and Queensland area. And they're primarily focused on drilling and trying to take a fast-track approach to commercialize it, and they're hoping to supply some U.S. markets. And their website, because they're in Australia, is .au, but it's topendenergy.com.au. Hytera. This is another Australian company. They're headquartered in Perth, and here, in case you're not as familiar with Australia geography, it's down here in the southwest. Sorry, I had a brain fade there. Southwest part of the country. So they're focused on exploring and producing natural hydrogen, obviously, and they're operating primarily in the American Midwest. And I'm going to show you some maps, but they've got interests in so-called Project Geneva, Nebraska, and the Nemaha, which you can remember how that's pronounced by, it's similar to Omaha, so Nemaha, Kansas. And they've completed an initial drilling program, and they're getting pretty promising results, both from hydrogen and helium. Helium is often found along with hydrogen, and it's a very valuable industrial gas, so not a disappointment that they're sometimes found together. And they have a partnership with Fortescue. So their website, unremarkably, is hytera.com. So here's a map of Nebraska up here, Kansas right here. This is featuring some petrochemical refining and ammonia. Not that much of interest to us, I don't think. But here's the Nemaha area. And here's the Geneva project. And this Geneva project is the well that Vyacheslav Zagonek put in. And I visited that and met him out there in June of 2020, right after COVID. We pulled our masks off just just to take the picture. But what Hytera has done is they're leasing that well back from him. I don't know all the business aspects of it, but at any rate, that's to orient you. That's what that project is. And here's Interstate 80 right here, not too far from that, not too far from Hastings, Nebraska. Another thing to point out on this map, the shading. You can see this dark blue shading here is basically they call it the prospectivity, or the likelihood of natural hydrogen occurring. And you can see this Nemaha is just right on a big dark area here. So anyway, their leases cover over 80,000 acres, and they've got their flagship project in the Nemaha, Kansas area, showing some of these are 96% hydrogen, which is really wonderful. And then in the project Geneva up here, not quite as concentrated, and it's not as dark blue, so maybe that makes sense, but more helium. And so, again, not a disappointment, because helium is a very valuable gas. So here's a map to kind of orient you. This area is just north of Interstate 70. It's off the map, but it's right down here, and then about 100 miles west of Kansas City. And so this shows Top End Energy acreage, Coloma acreage, and Hytera's acreage. And so they're all kind of concentrated in this area. And this so-called acreage is sites that they have agreements with landowners to do the hydrogen extraction. Leases, I guess you could say. All right, Gold Hydrogen, another Australian company based in Brisbane. And they have a Ramsay project in the so-called York Peninsula, which covers about 75,000 square kilometers. And apparently hydrogen in this area was first reported back in the 20s and 30s by geologists, which I was under the understanding that people weren't really noticing hydrogen because they weren't looking for it, and a lot of times the equipment they were using, the gas chromatographs and so forth, were zeroing it out. But apparently it was noted, but nobody knew or really had a use for it back then, so that wasn't developed. But now Gold Hydrogen is jumping in and developing that. So, by the way, don't be confused. The company that now goes by Eclipse Energy was called, and they're down in Houston, they were called Gold Hydrogen, and they changed their name. I don't know if it was because of the conflict with this Gold Hydrogen, but at any rate, two different companies. So Helios Aragon. So they're active in the Spanish Pyrenees in the so-called Monzon field. They estimate they've got recoverable resources of 5 to 10 million metric tons. They think the price target's going to be, and I'm sure this is at the well, somewhere between 50 cents to $1.25. And I've seen other places they talked about 50 pennies in euros, so half a euro per kilogram. And they're using, of course, as you'd expect, oil and gas technology to try to tap into this naturally occurring hydrogen. And they're anticipating that they'll be able to generate 55,000 to 70,000 metric tons per year, and also doing some exploring down in Africa, in Oman. So their website, if you want to check it out, is heliosaragon.com. All right, Hydroma. Well, this one is interesting because this kind of centers around that original discovery, I guess I'll call it, of hydrogen that was accidentally found down in Mali. But Hydroma is a Canadian company, but they are focusing on the African continent. And they were originally founded by an entrepreneur from Mali, so don't know why he's centered now in Canada. Probably had a connection up there, but this company was formerly called Petroma, around the petroleum aspects, and they've changed the name now to Hydroma to focus more on the hydrogen. So, like I say, they've started their exploration and so forth down in Mali. I'll show you a couple pictures here in a second. And they're actively developing different hydrogen sources and producing ammonia out of it, and also looking at storage and transport in Canada and Africa. Their website, also unremarkably, Hydroma, but it's .ca because they're in Canada. All right, so here is, maybe look at this top graphic. This is the African continent, just a chunk of it. You can see where Mali is here. And here is the town of Barakabugu. And I think I'm pronouncing that about right. And this, if you remember hearing the story, they were drilling for water, for a water well for the little village there. And didn't hit it. They hit some gas and didn't think much of it. But then a petroleum company came back thinking, well, maybe we can get methane or something out of this. And they accidentally, somebody was smoking a cigarette kind of carelessly, and it caught fire. And they looked a little bit closer and discovered it was hydrogen. And so that's kind of an anecdotal story that circulates about natural hydrogen. But here is the generator and so forth that they used for about 7 years to provide electricity for this village. So obviously not a real big generator. Suspect that's a Kohler. I've been looking at generators lately for my home. All right, H2AU. Now this is a UK company, and they were founded in 2022. And of course, they're using, oil and gas type of methods to try to identify and develop natural hydrogen. And by the way, I'm going to talk a little bit more about the techniques for finding hydrogen and some of the applications of AI and so forth to that as well. They have a portfolio of over 15 million acres of exploration rights in Africa and the U.S. And in 2024, they formed a strategic alliance with 45-8 Energy, which we'll go to on the next slide, to explore for natural hydrogen in the U.S., especially in Nemaha Ridge and in Kansas and in Iowa. So they've got a number of operator licenses in Kansas, and they've applied for exclusive rights on over 3 million acres in South Africa. So their website, h2au.co, which is kind of typical of British companies, that they'd have that suffix, I guess would say. So 45-8 Energy, mentioned them. They're exploring for both helium and natural hydrogen in Europe. They're based in France, and they've got active projects in the U.S., France, Germany, and Kosovo. And they have projects in partnership with H2AU, and there's their website, 458 Energy. So you're probably starting to get the feeling that a lot of the natural hydrogen exploration is going on in the U.S., Australia, France. We've only talked about that a little bit, but there's quite a bit of activity there. And a little bit in Africa. Now, it could be found just about anywhere, but those are the areas that seem to be the most active right now. Well, in Canada. Don't want to leave out our friends to the north. So Max Power Mining is a company up in Canada. They're one of the leading prospectors, they claim. They've got 1.3 million acre land leases, or however you want to say it, in Saskatchewan. And in late 2025, they had quite a discovery at what they call a Lawson site. 28.6% hydrogen, and they had very good flow rates and pressures, and pretty clean gas composition and clean, I think, in this case means not methane or sulfur. That could be another one too. But the composition is about 90% hydrogen, nitrogen that's coming out of the well. And there's apparently pretty good evidence of a pretty large reservoir there with a strong drive mechanism. And also some helium, which is a good thing. Although I will say it's my experience, or as far as what I know about trying to separate hydrogen and helium, is a little tricky. You can separate hydrogen and throw away the helium, or you can separate the helium and throw away the hydrogen, but trying to keep both, I think, is still a technology that needs some more development. So I can't speak to it any better than that, but at some seminars that I've been at, I've asked questions about that and haven't really gotten good answers on how you can practically separate the two, which could have changed since then. But anyway, this particular site, Max Power Mining, does other things besides natural hydrogen exploration. So if you go to their site, maxpowermining.com, put in the /XK products, SK products, I should say. All right, and then Les Français de l'Énergie. So this is a French company, obviously, and they're actually an independent kind of a utility, but they're very focused on low carbon solutions, and these are things like coal bed methane. Not sure how they make that a clean resource, but natural hydrogen exploration, solar, and biogas. And actually had a phone call with their CEO, Antoine Forcenal, and I want to give a shout out to Ray Pilcher and thank him for introducing me to them. But anyway, very interesting company, and they are looking, of course, at the U.S., which I'm getting a little ahead of myself here. But they have discovered some significant natural hydrogen deposits in the Lorraine region of France. And if you're not real familiar with France, this is basically the northeast quadrant, which is their kind of operating territory. They estimate it to be 46 million tons, and they're doing some advanced drilling to validate the concentration levels. And they see this as a major low carbon and cost-effective source to help with European decarbonization. And by the way, I just did a podcast, some of you may have heard it, with one of the ministers of it's called Batteries and Hydrogen in Finland. And it wasn't part of the podcast, but I had asked him if there was much natural hydrogen exploration in Finland going on. And he said there was, but he didn't feel it was developed enough to really talk about it on the podcast, so that wasn't part of the podcast. But what I did hear is that FDE is looking at prospecting in Kansas, and the reason's interesting. In Europe, apparently the subsurface is owned by the state, and so it takes, Antoine said it could take 5 years to just get the permits to start exploring, whereas in the U.S., they're held by landowners. So if you can get an agreement with a landowner, you can start drilling right away. So anyway, that is a big difference between Europe and the U.S., and that's also possibly why a lot of these European companies are looking at drilling in the U.S. So I thought that was interesting. By the way, I listened to a talk by an attorney, William Gardner Jr., who I saw at the Drilling for Hydrogen last year down in Houston when I was down there. And he said, you've got to be careful with the mineral rights and so forth. You might find property where you think you have gas rights, and if it doesn't specifically say that gas is hydrogen, it may not be included. So if you do get involved with any kind of exploration like this, let me know. I can certainly give you William Gardner's contact information. He is down in Houston. All right, and then website here, Français de l'Énergie in France. All right, so that is the folks that are doing the prospecting and the drilling and the exploring for the naturally occurring pockets. But there are companies out there that are looking at actually stimulating the geologic hydrogen. And they kind of fall into three categories, and it just happens to be three companies that are doing this. Each one has a different focus. So Eden Geopower, they're fracturing rock with electricity, and I'm going to talk in detail on each of these. GeoKiln, and by the way, GeoKiln is going to be one of the people on the panel that I'll be leading down in Houston March 12th. And they use heat, which makes sense, GeoKiln, to activate the reactions in these iron-rich rocks that can produce hydrogen. And then Vema Hydrogen, I think that's how they pronounce it. I don't know if it's Vema or Vema, but they're using water injection because water on certain minerals releases hydrogen. So Eden Geopower, again, they use electricity. They're calling it electrical reservoir stimulation or ERS technology. And they say it gives very much better control over the directionality of the fractures than injecting high pressure water. And apparently this is a proven technique. It's been used in the past across multiple geologies, so it's not a science experiment by any means. Minimal environmental impact because you're not injecting a lot of water. And of course, because you're not injecting water, you don't use much. So they're active in the U.S., the Middle East, and North Africa. I did see they had received multiple ARPA-E awards, totaling about $8.7 million for this technology, and they've raised $12 million in a seed round. And this is interesting. They are working in Oman, and they're collaborating with the University of Colorado in Boulder. Now, Alexis Templeton, the professor in Boulder, I had asked her to be on the panel down in Houston, and she told me she couldn't because she was going to be in Oman. And so this is obviously why, but they're working down there to use their technique to stimulate hydrogen release in Oman. So if you want to know more about them, it's edengeopower.com. So GeoKiln, well, they're using electrical heating, and I'm sorry I don't know if it's microwave or how they're doing that, but I assume it's probably microwave. They've been selected by, again, Bill Gates Breakthrough Energy to be a fellow. And what a Breakthrough Energy fellow does is or receives, I should say, is they get some R&D funding. They apparently have classes or something that they attend. It's, they say, world-class curriculum. Some one-to-one mentorship, and access to the Breakthrough Energy Global Network. Now, GeoKiln is collaborating with Hytera, so Hytera is not all about just finding free hydrogen, but also stimulating the production of it. And then, like I mentioned, the GeoKiln is going to be on my panel down in Houston, and their co-founder and chief commercial officer, Lorna Ortiz, is going to be on that panel. So their website, geokiln.com. So by now you're probably getting the impression that I'm really pretty active in this geohydrogen, because I think it's super important, and I'll talk about why here in a little bit. Again, Vima Hydrogen, now they call their process engineered mineral hydrogen. I guess everybody wants to have a buzzword for it. And they use a catalyst which gets absorbed by the rock, which accelerates chemical reactions and generates hydrogen. And they've got pilot wells in Quebec that they're testing. They also have, and I featured this a couple of months back in the newsletter, they've got a 10-year agreement with the company Vern to supply hydrogen for California data centers, up to 36,000 metric tons per year of hydrogen. And Vima actually stimulates and generates the hydrogen, and then Vern is got the electrolyzers and so forth to turn that into electricity. And here's Alexis Templeton again. She's on Vima's scientific advisory board. So Vima's website is vima.earth. A little bit of a twist there. All right, so let's switch gears again and talk about some of the search tools for finding natural hydrogen. So HiReveal, I'm going to go into details on each of these. That's a French company. GetTech, they've got a digital platform when they combine 3D subsurface models and machine learning. I'm going to talk a little bit in depth about artificial intelligence and machine learning here in just a minute too. Mantle 8, not sure where that name comes from, kind of intriguing, but they've developed something they call Horex, which I thought sounded like a Dr. Seuss character, but anyway, that's the name of their process. And it's an AI-boosted imaging system that can create 3D views. And it's, we'll talk to this a little bit in a minute, but apparently we're still kind of in the development stage of trying to find and visualize and characterize and quantify subsurface hydrogen. And of course, we've got decades or even centuries maybe of experience with petroleum and those kind of search things, which are being applied, but this is a little bit different. And we'll go into some detail there. Max Power, we already talked about them, but they've got, in addition to just doing drilling, they've actually got some modeling tools and some AI-assisted things. Another company, Excalibur Smart Mapping, they're using airborne exploration technology, which you'd expect. And I'll talk a little bit more about what LiDAR is and how that works for this particular process. And then Snowfox Discovery, another UK company, they've got backing from BP, which is now called, of course, Beyond Petroleum, and formerly British Petroleum, and Rio Tinto that is using AI. All right, so to go through these companies, High Reveal, so they have both data acquisition and analytics. One of their co-founders here's Vyacheslav Zagonik again. He has kind of stepped back from drilling to look more at the techniques for finding the hydrogen. I guess the analogy I'd use is instead of mining for the gold, he's supplying the gold miners. So to think back to the gold rush days on how some people made money in that paradigm, I guess you could say. So Vyacheslav was a guest on the Hydrogen Nowcast episode number 61, if you want to go back and listen to that. They've got 3 products. They've got this one that's looks like it's an app, just software, called iOrigin, high-resolution predictions by taking field data and microbial activity, which you may have heard of things like fairy circles or whatever. When hydrogen comes to the surface, it can affect the foliage, pro or con, and that's one of the ways to find subsurface hydrogen, although generally if it's leaking to the surface, it's not being trapped, so it's there but maybe hard to capture. Something called HBox, which is hardware that can provide data flow and enabling precise, timely decisions based on current subsurface hydrogen dynamics and conditions. Something called Sniffer, makes sense for trying to sniff hydrogen. And this finds hydrogen at the surface and can look at the dynamic fluctuations and apparently helps save some time in exploring and helps make faster decisions. So they are actually in a partnership with GetTech, which we'll talk to next. So High Reveal, again, they're a French company, and but they have some folks here in the U.S. We had one of their reps at the CERAD conference at the end of October that we had up in Boulder. He was actually on my geohydrogen panel there. So GetTech, again, as you'd expect, applying geoscience data and trying to do geospatial kind of analysis with their software products. They also use gravimetric and magnetic data. I don't know how familiar all of you are with a lot of the geosciences, but the U.S. Geological Survey has mapped, I think, the whole world, but certainly the U.S. in great detail, showing the different variations in the gravity, showing different magnetic data, conductivity of the soil, and so forth. GetTech is doing temperature depth maps and depth to basement rock. And I had to look at this. Basement rock is a term that geologists use to talk about the real solid bedrock. It's kind of termed as the rock that's between the molten mantle and the eroded or sedimentary top layers of rock. So it's getting down to that very ancient type of rock. So GetTech is not just focusing on natural hydrogen, but also petroleum and also geothermal, and they can actually help folks that want to do carbon storage and sequestration. So, unremarkably, gettech.com, their website. Mantle 8, again, combining the geology and geophysics and geochemistry to create these different maps. I think all these companies are kind of doing very similar things and using a lot of similar databases. Some of them are using other imaging techniques like the laser that I mentioned. And here's our Dr. Seuss character again, Horax pilot project, which is actually being done in the Pyrenees. And so that's the mountain range between France and Spain, of course. And their website, mantle.8.com. Max Power again. So they have this tool they call Max LEMI, which is Large Earth Model Integration, LEMI. And they're going to use a lot of artificial intelligence for the analysis and the rollout of this. And let's see. So this, by bringing artificial intelligence in, as you can imagine, or machine learning, kind of depends. Looks like I had a mouse bounce here. The ability to review and interpret large data sets and really cut the analysis time from what humans might take months to something very much faster, of course, with these techniques. Again, Max Power Mining, as we saw earlier.com is their website. And Excalibur. So again, using geodata, and they've got actually an airborne geophysics fleet for doing the sensing, and trying to integrate and fuse some of the different data to build they call it a unified Earth intelligence capability. ExcaliburMP.com. And lastly, Snowfox, and I almost didn't include them because I'm going to show you here. This is all I really could glean out of their website. They might be kind of a very early startup, or I don't want to say a wannabe. That sounds kind of negative, but I didn't see that they were actually putting anything out there yet, but possibly one to keep watching. So probably worth mentioning. So snowfoxdiscovery.com. All right, so another shifting of gears here. I wanted to really kind of go into, some of you may be a lot more expert at this than maybe I am, but just talk about what the difference is between artificial intelligence and machine learning. And because I think that's, well, it's a point of confusion, at least in my mind, and I think for some people as well, of what's the difference and how does it work. So artificial intelligence is really kind of a broad concept. Basically, you're just saying that you're trying to create a machine that can simulate human intelligence and behavior. Obviously. And then that's really a long-term goal. I think it's going to be years, if not decades, before we're there. There's that, maybe some of you remember Turing. I'm drawing a blank on his first name, but he helped crack the Enigma code during World War II. And he came up with this idea of the Turing test, of being able to create at least a software program that could fool somebody to thinking it was actually human. And so, that's kind of where this whole idea of artificial intelligence came from. But machine learning is a little bit different, and that is kind of a subset of artificial intelligence that allows machines to learn from data. So you're constantly refining by just feeding it more and more data, and it draws conclusions based on that, not really using any kind of an algorithm of, how this is how it's calculated or whatever, but it just basically looks at the data rather than being programmed to go find something and do it. And maybe a good example of this might be a pedometer. So you have a pedometer, and it has accelerometers, and it can sense motion. And so what you do is you train it. You just say, okay, this person is walking. This person is, you can sense motion, but they're not walking. And so it doesn't have to understand it or look at the fundamental rules or anything like that. It basically is just taking data and just crunching it. And really, this is the primary method that's being used today for pattern recognition and statistical models. And it's quite powerful because it can oftentimes find patterns that you probably wouldn't find any other way than just simply crunching through just tons and tons of data. I don't know if anybody can do better than my explanation. If you want to jump in, please feel free. And we can always come back to that. So here's maybe just a little bit of a table talking about the differences between artificial intelligence and machine learning. So artificial intelligence can use a variety of methods to solve problems, sometimes logic, rule-based logic, knowledge graphs, whereas machine learning is specifically using basically statistics, how often this pattern occurs and so forth, to just look for patterns in the data. Again, the goal to simulate human intelligence, that's AI, and then machine learning. And this allows systems to learn from data to kind of optimize that specific task. And the artificial intelligence may not necessarily require constant automated learning, But machine learning definitely improves over time by being exposed to basically more and more data. So here's a graphic where I guess we could say all machine learning is artificial intelligence, but not all artificial intelligence is machine learning. So you can see the nested way this is kind of portrayed graphically here. So hopefully that helps us all understand this a little bit more. Any comments? All right. So the key artificial intelligence techniques that are being used for hydrogen exploration, satellite image analysis, as you kind of suspect, subsurface modeling, and then Raman, I don't know if it's Raman or Raman, and it's not noodles, but that's LiDAR technology. And LiDAR stands for light and, I'm drawing a blank all of a sudden. Light detection and ranging. And sometimes it's called laser detection and ranging because I think all of it uses laser, not just the average light bulb type of light. So I know that one of the things that LiDAR is used for, archaeologists use it. For example, down in the Amazon jungle, they'd like to know what the pattern is in the ground, if there's old foundations or roads or something, and they can't see it through the foliage, but LiDAR can actually penetrate that foliage to see that. Now, what Raman is it actually is an broadcasting laser in the air to look at the composition of what's in the air, and so they can detect hydrogen and, of course, water vapor and other things like that. So that's a difference there. So satellite image, they can look for these small circular depressions that often indicate the hydrogen seeps. Accuracy up to 95%, they say. Subsurface, using seismic and all kinds of other geological data, which can be pretty robust. I know the map that the USGS put together of the hydrogen prospectivity used at least 12 different databases, and I can't tell you what they all are. But they're trying to look for the three highly indicative circumstances of a good source rock, a carrier bed, and a seal, a way to seal in the hydrogen. And then here, the LiDAR technology is broadcast into the air, not at the ground, and that's used to detect hydrogen in the atmosphere, which could identify potential seepage. And by the way, I may have mentioned this before, but at one time, I know Vyacheslav Zagonik had told me that the Earth is oozing, I'll say, so much hydrogen that we actually, and it leaves the atmosphere, we're actually leaving a trail of hydrogen, kind of like a comet. I mean, it's not real concentrated, but, and that's interesting because you hear people talk about, oh, hydrogen leaks could affect the climate, it could be considered a greenhouse gas. Well, I bet you anything that the amount of hydrogen leaks from mankind are going to be hundreds of orders of magnitude less than what the Earth is actually outgassing. So there. Anyway. All right, so now let's talk about something a little bit different, and that's getting clean hydrogen from oil reservoirs. And I use clean to indicate something that has very low to no greenhouse gas emissions. The whole idea of green has just gotten so watered down. It's kind of like food that's called natural, or nowadays even, it's keto. Oh, it's keto friendly. Well, it's become almost a marketing term. I don't like using colors. They're so misused. People can't even agree. Natural hydrogen is called sometimes white, sometimes gold hydrogen. I don't go there. I just call it clean, but I mean, clean is a relative term, and I mean it to mean, or intended to mean, very low to no greenhouse gas emissions, and that's methane, carbon dioxide, or NOx too, for that matter. So hydrogen generated in oil reservoirs. Proton H2, I've been talking about them for 6 years now, since 2020, and when I had them on the podcast. They use oxygen injection. All of you probably have heard this so many times now. You could teach this, I think. And only hydrogen is brought out of the well using filtration. So they have a pilot well, and I actually, right before this call, I was on a call with Calvin Johnson at Proton H2, and he verified that their well is still operating. I asked Calvin about using these oil reservoirs for powering data centers. And I said, obviously, this is a finite resource. We're using petroleum that's in the ground. And he reiterated something I heard before, and that is that almost every oil well ever drilled still has somewhere between 50 and 75% of the oil in it. It just wasn't economical to extract it. And he said these oil reservoirs could go 20 or 30 years providing hydrogen for data centers. So that was good to know, because the natural hydrogen is, in many cases, a process that's ongoing. If it's radiation or water or whatever, it's continuously producing hydrogen. So those could run indefinitely. But the oil reservoirs, if we want to use them for powering data centers, apparently decades of work out of those. And I have to think that a data center today probably is going to be gone or something else in 20 to 30 years. Still, there's talk about cost below 50 cents a kilogram at the well, which is why this is so important for our hydrogen for powering transportation or replacing natural gas. And they're a member of this Path to Hydrogen group, although even after talking to Calvin, I'm a little confused about this, because there's a parent company called H2 Genesis, which is in there as well. Path to Hydrogen is a German company that was formerly Philo Max Cap. So I've got to get that sorted out. And Calvin and I are talking about doing another podcast, so maybe we'll explain the relationship here between these companies. And I think what it all comes down to is it's some of the same investors that have invested in both, and that's where that comes from. And then Calvin is going to be on my panel in March down in Houston to talk about geologic hydrogen. And the podcast, we're up to podcast 98, or I'm up to podcast 98, and so Proton Technologies, as it was known at the time, was on episode 13. So obviously this is something I've been looking at and a big proponent for quite a while. Their website, protonh2.com. So the other company doing this, generating hydrogen out of oil reservoirs, is Eclipse Energy, and I mentioned them earlier. They inject microbes into oil reservoirs that munch and release the hydrogen. And again, only hydrogen is brought out of the well using filtration, so I'd consider it clean. They do have a pilot well operating in the San Joaquin Basin in California. And again, probably below 50 cents a kilogram at the well, which is, we've got to be there or even lower in order to compete with diesel for heavy-duty trucking, as well as competing with natural gas. So they were featured on episode 89 of the Hydrogen Nowcast, and their CEO, Prab Sekin, is going to be on my panel down in Houston in March. So their website, eclipseenergy.co. All right, shifting gears once again. I just found out, I didn't realize this, although this press release I think came out almost a year ago, is that USGS and Colorado School of Mines have a joint geologic hydrogen program, and they consider it the first collaborative effort on geologic hydrogen between a federal agency and academia. So their goals are to basically define a model that can identify sources and the migration pathways and the reservoirs and the traps and seals. And a lot of this is known, but I think there's some unknowns there that they feel like they'd like to really just nail down a little bit better. They hope to define some surface exploration approaches, including the remote sensing, which we've just been talking about, and surface geochemistry. Identify subsurface exploration tools that can include geophysical tools. These are things like, I know when I was in college back, golly, this was 55 years ago, I worked for a time for the Geological Survey, and they would send current down into the ground that they could determine what the different rock types were. They would actually use very distant electrical storms, lightning and so forth, and as those electrical waves passed over the soil, you get different tilt, and they could sense those things. So there's all kinds of data that they can collect with sensors. And nowadays, because of all the new artificial intelligence techniques, we can analyze all of that. And then they want to talk about the reactive transport modeling. I'm not even sure I know what that means, but probably how the hydrogen moves and gets trapped in the geology. So kind of cool. We've got this right in our backyard here, USGS and School of Mines. All right, so I did want to mention, this is the last thing I've got, and the state of Michigan has, and some of you may have seen, I featured this in the last newsletter, talking about pursuing geologic hydrogen. So Governor Whitmer, looks like one of the first things she did in 2026 was to sign into law this executive directive, which was to, well, basically this is kind of the, what do they call it? The declarations at the beginning of these things is Michigan has been identified as one of the most promising regions in the world for naturally occurring geologic hydrogen. And indeed, when you look at the USGS map, almost the entire state of at least the lower peninsula of Michigan is just deep dark blue. So they think it's got really strong geologic hydrogen potential. And obviously, geologic hydrogen has the potential to fundamentally reshape our global energy systems because of the low cost, and which will, of course, help reduce emissions. And it presents a path to produce clean energy at a scale, that's another thing, and a price competitive with fossil fuels to reshape our global energy system. So really great to see that Michigan is doing that. And Elliot, I know you've got some activity up in Michigan. You've got your hand up. Why don't you go ahead? And you're still on mute. Elliot, you're still on mute. Let me see if I can unmute you. Oh, you're off mute. Okay, but I don't hear you. Well, Elliot, we're not hearing you. It's not, I got my speakers up. Elliot, I don't know. I'm not hearing you. I don't think
Can you hear me now?
Oh, now I hear you. There you go.
Yeah, I have to switch around here. Sorry about that. I was just going to say that we have a lot of support from the state of Michigan, and hydrogen does. They're very active and proactive on developing clean fuels, and their main objective is to fuel the auto industry and to have it grow. And Michigan has a lot of oil and gas activity and has historically. So if you look at that USGS map, you'll find that Michigan is like number one
Yeah.
location in the country. So southern part of Michigan. So anyway, I just wanted to share that. My associates up in Michigan have had spent a lot of time with the governor's office actually, and their people, and I think they're welcoming participants.
Yeah, great. Well, glad to see this, and I'm going to kind of use this as an example with our energy office here in Colorado, and hopefully maybe get to the governor with this and say, hey,
Yeah,
you don't want to let Michigan beat us. Come on, let's. We've
yeah,
got a
they're
lot of
excellent.
geologic hydrogen here in Colorado too. Let's get
Oh, of
a little
course, and that's what
competition
we were
going.
hoping for here.
Yeah, yeah. Well, and you say Michigan does have a fair amount of oil and gas. I didn't realize that.
Oh yeah,
Okay.
yeah, they've been an oil and gas producer for a long time. They have a
Okay.
whole reef play up there that's been going on for many many years.
Okay. Well, that's good because then they've got a lot of companies and people there that
Yeah.
know about drilling and so
Well,
on.
and the other thing is that they've got a lot of money up there. They're willing to spend it.
Yeah, yeah, good. I know Michigan, or I'm sorry, Minnesota had a problem. They were looking to explore for natural hydrogen and helium, and when I may have mentioned this on the meetings before, but they went to the state to get permission, and the state said, "Well, we don't know how to prove it. We've never approved any kind of gas drilling in the state." And so they actually got with folks in Colorado to help them kind of craft
Mhm.
rules and regulations and laws and stuff around and
Yeah.
safety things around drilling.
Yeah, I'd say that. By the way, on the overall hydrogen concept and working with Michigan and what they're trying to do and open up hydrogen there is a good example for what we can do here and build here, um, outside of looking at California.
Okay. All right. All right. Well, I'm going to press. I was worried about not having enough material, and it looks like I might have a little bit too much, but I only get a couple more slides. But this directive, which I think is good for other states to take a look at, is that they've basically engaged two state agencies. Now, not every state's probably going to have these same agencies, but they've got one that's called Environment, Great Lakes, and Energy, which has been tasked with charting the permitting pathways, so getting that laid out. So when these companies come in, there's a basis for them to be judged or regulated or whatever. They want to also model any kind of emissions impacts, which I would think would be pretty minimal. Again, I wouldn't consider hydrogen to be a greenhouse gas, but if there's some other gases present, of course, you want to make sure those are controlled. Check to see that the infrastructure, whatever that may be, is ready. And of course, workforce training, which is good to see that listed as well. And then their DNR. I know Wisconsin has a DNR. Some of the other Midwest states have this Department of Natural Resources to basically help sort out leases. And again, as I mentioned earlier, with this attorney down in Houston said, you got to be careful because you may think you've got all kinds of mineral rights, and somebody may say, well, it doesn't explicitly say hydrogen, so I don't know. So you got to be careful. And also to just sketch out some of the exploration strategies, how they're going to do that and do those leases and so forth. So I think, most important, let's summarize what we just talked about. So I categorize this rather than positives and negatives as pluses and minuses. So on the plus side, hydrogen's really thought to be available just about everywhere. And the USGS has said very conservatively that even if a small percentage of this estimated volume is recoverable, hydrogen alone could probably meet global energy demand almost indefinitely. And it, in many cases, is constantly produced, so it's a sustainable process, renewable process through these geologic processes that make it. And generation can be further stimulated with heat and water fracturing, as we talked about. Looks like everything I see from all of these folks around the world, I think and I'm sure they're not giving us their best and final price yet, so it looks like it's going to be below 50 cents a kilogram. And that's where it's got to be if by the time you transport it to compete with diesel and to compete with natural gas, in cases where it makes sense to use natural gas. Now, I don't think it makes sense to put hydrogen in natural gas pipelines to send to homes for obvious reasons. But for like making steel, you can use hydrogen to remove the oxygen from the iron ore, just like we currently use coke to do that. And there may be some other things where it makes sense to use hydrogen instead of natural gas. And those probably are going to be dedicated pipelines to do that. So obviously not in every case. And then skills and technologies for the oil and gas industry can be adapted for the locating and the drilling and the extraction. So those are on the plus side. On the minus side, commercial viability and scale. Really, it's not known yet if these pockets, even though hydrogen may be everywhere, is it just small amounts, but is it large enough, and is it concentrated enough, and is it being constantly replenished that it could make, be financially or economically viable to develop it. Again, replenishment rates, we don't know that yet. It's going to take some time on some of these wells to see if they go dry real soon or if they just keep on giving. And don't really have real good, technologies to pinpoint it. Although, I haven't really heard that anybody who's put a hydrogen well down has come up with a dry well yet. I could be wrong, but I think most of these folks have hit on the first try. Now, whether it's a lot and it's at a high flow rate remains to be determined. And then, how it moves in the subsurface, how it collects in these traps or dissolves in groundwater aren't well understood. And then in some places, there's lack of clear legal permitting and so forth. And so I think it would make a lot of sense to get those in place before anybody starts drilling and then gets disappointed because they're not allowed to do anything. So I am a couple minutes over, 1 minute over. Um, I'm amazed to hit it on target, but I am happy to stay on a little bit because this was only a 1 hour meeting. If anybody wants to make any comments or ask any questions or anything else, I'm happy to hang out here for a minute.
Ryan, Bill here.
Hey, Bill, good to hear from you. How are you?
Fine. May I reflect on what you've said over the last hour?
Yeah, absolutely.
The geokiln folks gave a presentation to the hydrogen interest group here in Alaska a while ago, and I followed up with them and found out a little bit more about what they're trying to do. Of course, they depend upon iron-rich rock being not too far below the surface. It's the interaction of water with the iron in the rock that causes the evolution of hydrogen by heating it a little bit. And they say they will heat it with electricity. So it's something like priming the pump. They've got to get the hydrogen moving so they can run it through a turbine on the surface and make electricity so they can heat the rock so it'll go faster and produce some hydrogen that they can then sell. So their success depends upon the ubiquity of supermafic rock, which is high iron density rock. In all the cases of what you've discussed today, we still come down to the problem of moving and storing, delivering and dispensing the hydrogen so that the energy is where it needs to be. And I wonder if your Texas panel is going to include anyone to bring you up to date on the High Blend project, the several DOE national labs that began their phase 2 study on High Blend, which means hydrogen blended into the natural gas in extant pipelines, or even 100% hydrogen in pipelines someday, especially if we wean ourselves from methane and replace it with all these sources, alleged at least, and to be discovered, of geologic hydrogen of various kinds. And finally, the prospecting risk is there, I think, as you alluded to lately. But many of these places where we might find it coming out of oil wells slowly, if we can just somehow use the extant pipeline network, even liquid oil pipelines can be converted to carry hydrogen, perhaps. That might be the secret to moving it and storing it by compressing it in the pipelines, packing the pipelines to some extent. Thank you. Good job today.
Well, thanks, Bill. Appreciate it. So let me comment on a couple of things. So there, and I probably didn't cover this, did I? There's really three mechanisms that generate hydrogen. There's the iron-bearing rock, which can be water causes the hydrogen to be released, but there's also nuclear effects. Uranium and thorium underground actually will release hydrogen from water, and if you've got some kind of a cap, that'll cap and store that, so to speak. And then there's also the mantle itself is outgassing hydrogen, and so there's just this constant stream of hydrogen bubbling up from the surface. And if you've got some kind of cap rock or a salt dome or something like that, that may collect hydrogen. So there's more mechanisms than just the water. And to your point about transporting and storing, the nice thing about geologic hydrogen is apparently it's almost everywhere. And so my thought is that you wouldn't have to transport it. You'd have to transport it miles maybe, but not hundreds of miles. And so that's the hope there. And you're talking about high blend. No, we're not going to address that. And frankly, we could have probably a 3-day, all-day seminar on geologic hydrogen, and the panel is just going to talk about a few specific things. But All really good points, and you are absolutely right. We don't know yet. We don't know how this is going to pan out. It shows a lot of promise. I think it seems ubiquitous enough that in probably a lot of cases it's going to succeed, and not every well is going to be a hit or a gusher, I guess, put it that way.
One more thing,
Sure.
the principal author on the report 4 or 5 years ago that got everybody stirred up about hydrogen being a greenhouse gas is Steve Homburg. He's the chief scientist at Environmental Defense Fund, EDF, and he's um, an acquaintance of mine. So if you ever have a chance to ask him to discuss what you just talked about in his context, might make for an interesting session for this monthly call or someplace else.
Yeah, or maybe even a podcast. And I don't know. I don't think I ever read his report specifically, but I don't know if he compared what mankind might release to what the natural outgassing, or if he was even aware that the Earth was naturally outgassing. And I don't know if anybody knows how much it's outgassing. So that's, I guess, speculation there. All right. Happy to continue if anybody else wants to comment or ask questions. Well, I hope I didn't.
Can you hear me?
Yeah. Oh, go ahead. Is that you, Elliot?
Yeah, yeah, it is. I thought that was a really great presentation. The overview of it gave me a little bit more background. I know you've been working really hard on, particularly the injection of into existing abandoned oil wells and things like that. I think that one seems to be the least risky,
Yeah.
as opposed to on the exploration side of it, which is very interesting. And I guess we'll continue to learn more as you develop this. But for us, what we're trying to do in the hydrogen side of it is to find the lowest possible cost of hydrogen so we can bring it to market and it's affordable and comparative to diesel or even gasoline. But diesel first for us, as we're looking at the heavy duty truck marketplace, mostly mid duty to heavy duty trucks. So
Yeah. Well, and Elliot, that's the key because in order to get, I mean, hydrogen's got to be almost at parity with the price of diesel, which depends where you are in town, but what is it,
agreed.
yeah, 320, 350 a gallon. So we got to have hydrogen that's maybe let's just say 350 a kilogram. Well,
Right.
it costs you probably $3 a kilogram to move it. So
Yeah, just to move it, just to
yeah,
transport it after you bought it. And the thing is it's got to come from a long way for us too. So for us, it's a loss leader in our overall concept of what we're doing, which
right.
hopefully we'll talk about next month. But the thing is that if we can get it locally, which is far preferable, and at a low cost, then that takes away that part. Now, the only other solution that we need to work on as the industry is the actual cost of the trucks and the equipment's going to be exactly what equipment costs. Storage of dispensing, all of that. It costs the same amount to build storage facilities for gasoline or diesel. So just maybe a little bit larger, a little bit better containment, but the rest of it, it all has a price to it. And the more that's out there, the less it's going to cost. So
Well, I did just a back of the envelope estimate on what it costs to buy a truck, to put tires and fuel in it, to pay a driver, to get insurance and so forth, and all that. And I come up with for 50 to 100 miles, it's not much different, but it's probably $3 a kilogram just to do that. And that's moving it as
yeah,
a gas. If you move it as a liquid, it's even a little bit more expensive because the equipment and the energy to keep it a liquid
well, yeah,
hits you. So, you've got to be down 50 cents a kilogram at the source or under. I think even 35 cents would be a little bit better in order to provide fuel for heavy duty trucking. Now, cars are different because cars, you can sell hydrogen at $8.75 a kilogram. They're much more efficient. and they'll pay the same price per mile. But for the heavy duty truck, everybody says, "Oh, heavy duty trucks, that's the application for hydrogen." Well, that's the hardest one to get to the price target.
Right, it is. And the thing is that if anybody's watching what's going on with the fleets out there, they're hurting right now as it is. Their main problem right now, their main cost is the labor cost, the drivers, and all of that. That's why you're going to see more and more autonomous. That's another discussion, but autonomous vehicles, because they don't have that overhead that they have with the drivers, the HR expenses, the
Right.
insurance and all those kind of things. So,
And workman's
um,
comp. And,
yeah,
yeah.
so that's their biggest expense. And
Right. Right.
when they can bring that down, and then bring down the cost of, if the cost of equipment is compatible to what it is today, they'd be using hydrogen trucks.
Right.
But it's not.
Right.
So, and that's
And
the thing we've got to work on.
well, right. And even if they would love to go to a hydrogen truck and they're a believer in it and they've drunk the Kool-Aid, whatever, they can't because they can't pay any more for fuel. Their competitors then would put them out of business.
Yeah, virtually. Yeah, unless that's why when the grants went away, that any opportunity for parity just doesn't exist. So
Right. Right. So
thank you, Brian, very much. Appreciate it.
yeah, thanks, Elliot. Appreciate the comments, and
And
Billy,
then
appreciate.
next month maybe we'll be ready to go.
Yeah, yeah, we'll put you on the air, so to speak.
All right,
All
sounds
right.
good.
Anybody else? Any other comments or questions? Well, thank you all for your attention. I hope I didn't choke you with too much information. But as always, I will put these slides on the website so you can mine them for data if you want. Yeah, Bill, another thought? And you're on mute. Oh, no, I guess not. All right, everybody. Well, with that,
Can you hear me?
now you're back. Hey, Bill.
Okay, sorry. In the luxury of overtime here, do you want to wax philosophical for us on where you think we are in the hydrogen cycle? It has its ups and downs and seem to be in a downer, at least in this country right now. What's your perspective on that?
Well, here's what I think. I think hydrogen can compete with diesel, gasoline, natural gas, but it's not a real compelling competition. In other words, if we could sell hydrogen at a penny a kilogram, man, the world would beat a path to your door, as they say, with a better mousetrap. The problem is it's close, and so now what we have to do is we have to ask fleets, we have to ask individuals to switch over to something else that's new, that doesn't have a robust supply chain yet, and so forth. And so that's making it go slow. And, look at how um, profitable and everything else solar and wind has been for the utilities. But those all got some subsidies to get going. And especially, I guess we could say the Chinese are subsidizing it because they're putting out really cheap panels and cheap wind generators. Um, it almost seems like it's going to take a little bit more than just being competitive. Now, what that little bit more might be is the growing urgency that everybody's feeling about climate change and wanting to do something. I mean, if it wasn't for that, we wouldn't even bother with hydrogen, of course. So, how does that balance out? If hydrogen's about the same price, maybe a little cheaper, but we're worried about, the planet burning up, is that enough to motivate everybody to do it? I don't know. Unfortunately, with the Trump administration actually fighting everything, I think they only know how to destroy. Oh, did I say that out loud? Um, that's hurting it a little bit more. But I think eventually we're going to get there. Like Churchill said during World War II, Americans can always be counted upon to do the right thing once they've exhausted every other possibility. We're kind of there with the climate too. I mean, we're thinking about it, talking about it, thinking about it, and we're confusing motion for action, which is what Ben Franklin said. So I don't know. I hope we get there. I've been at this 6 years. I never thought it would take this long to get a frickin' fuel station going. Um, I had a dream, and I'm starting to think maybe it's just a dream, but I'm going to keep trying. What else am I going to do?
Thank you. Well said.
All right. Well, maybe
As they said once, Brian, endeavor to persevere, brother.
Yeah. Oh, yeah. I used to work with a guy. That was his favorite saying. So
Yeah.
we'll keep on keeping on. Well, I tell you what, why don't we at that point adjourn and thank you all, and we'll see you again next month, and maybe you'll have something to tell us by then, Elliot.
I hope so. That
All
looks
right.
good. All right. Thank you.
All right. Thanks,
Bye.
everybody.
Okay.